Hello and welcome to Computer Learning Channel by Accelerate Computer Systems. My name is Arun and I will be your trainer today. On this channel, our goal is to explain technical computer concepts from the very basic to advanced at one place in a very easy to understand language with more and more examples and visual references. We also try and keep the videos short to keep you engaged. Today, we are going to talk about a very interesting topic, the OSI model. Let me give you a very brief background as to what is an OSI model. In essence, this is a step-by-step process how data is prepared for exchange between computers by converting application data into ones and zeros, which can then be sent over to other computer over wire, Wi-Fi or fiber optics. You might ask, what is the need to have an OSI model in the first place? Okay, let's find this out together. Initially, the computers, they worked independently. Slowly, when the computers, they started talking to each other, sending messages to each other, every manufacturer had their own way of communication and that way they were not compatible with each other. This means that an IBM computer could talk only to another IBM computer. This was counterproductive for everyone and not good for the business. And that is when the large manufacturers, they came together and agreed to have a vendor neutral networking model or process so that all the computers could talk to each other seamlessly. To help realize this, the International Standards Organization created the OSI or Open Systems Interconnection Model. This model standardizes the process of exchanging information between computers. This model also helps in easily troubleshooting connectivity issues. Now, every manufacturer followed the same process for sending and receiving data. This made communication between different manufacturers seamless because everyone had to implement the same protocol. Let's try to understand the process better with an example. As we discussed in our initial videos, the data is not sent as you see it on your screen, like a picture. This data, like a picture, it needs to be collected, broken down into small parts if it is too large. Source and destination IP address and MAC addresses, they need to be added, that we saw in our previous videos. And then all this needs to be converted into ones and zeros and sent over the medium like Ethernet, Wi-Fi or fiber optic cable. In the example that we have, we'll see what happens to the data if we are trying to access a website. What steps are taken in the background in preparation to exchange data with the remote computer? Let's see. When you open a browser and enter a website address and press enter, it initiates the process of sending information to the remote computer or server. At this point in our example, the information is still with the application called browser. Information is forwarded by browser to the next level, that is called presentation. And this is the process of encoding the information received from the browser so that it can be easily understood by the other computer or server. Now, you might ask, what is encoding exactly that we are talking about? Let me explain this with an example. Here is Notepad, and I'm going to type some text and some special characters. Let me now save this file. Now, while saving, I can see the option down at the bottom about encoding. You have different options. Default is UTF-8, but for the purpose of demonstration, I will select ANSI. Once I save the file, I'll get a warning message that some special characters might not be displayed correctly. Let me go ahead and still save the document. After saving the file, notice that the special characters that we had entered are not visible. Instead, we can see two question marks. This is because the particular encoding that we chose while saving the document does not support special characters. So if your computer sends information encoded using ANSI, chances are that the information will not be understood by the destination computer or server if there are special characters. We know that computers, they work with ones and zeros. Encoding helps in displaying the characters correctly. And when we are preparing to send data over the internet, this data needs to be encoded correctly so that any computer can understand it. There are different encoding options like base 64 or ASCII. And These are used by the system very often. Encryption of the data is also handled at this particular point of time. Once data is encoding is complete, computer needs to establish a session with the remote computer. Now this is the process of establishing a connection with the remote computer, which is called a session. It is created, managed and terminated at this particular level. Now that a session has been established, data needs to be prepared and transported. To do that, the data is broken down into segments because the entire data cannot be sent as one package if it is too large. It is important to note that these segments are numbered sequentially so that the other computer knows if the data is received completely or if something is missing. Let's say if you're sending 10 packets in a sequence and the other computer or server is missing the packet number 8. It will send a message to your computer to resend the packet number 8. A decision is also made here if the system must ensure that all the packets are delivered or if it is okay that some packets are lost on the way. For example, if you are sending a file, we want to make sure that complete data is received at the other end so that the file can be read. But let's say if you are watching a video or listening to an audio, it is okay to lose one or two packets because continuity here is more important. And this purpose is achieved with the help of protocols TCP and UDP. We'll talk about this in one of the future videos in detail. Another important step taken at this stage is the segregation of traffic. For example, the data requested for a website will be marked distinctly from the data requested by Outlook. This is to ensure that the system knows which application requested which data. Now, you might ask, how can this traffic be segregated if everything is being sent over the same cable? This is done with the help of a number that identifies individual application, something like a product number. So even though a store might have multiple brands of water, the system identifies each with the help of a barcode, which is different for every brand, every size. Similarly, every application that sends or receives information is assigned a specific number, which tells the system which application is sending or receiving the traffic. For example, any HTTP request which is associated with browsers has a number 80 assigned to them. Number 25 is assigned to emails. File transfer applications have the number 20 and 21 assigned to them. In technical language, these numbers are called port numbers. There are port numbers from 0 to 65,535. Port numbers from 0 to 1023, they are called system ports. These are used by applications already known and these are fixed. For example, 80 will always be used for browser. Then there are registered ports from 1024 up to 49,151, which can be registered by companies and developers and used. And then we have dynamic ports from 49,152 up to 65,535, which can be freely used while sending a request. For example, while sending a web page request. Let us see this process with the help of an example. Let's assume that the computer on the left wants to fetch a website from the server. We know that web requests are sent to port 80. So the computer sends the request with a random port of 65,263 as source port and destination port of 80 along with the source and destination IP address. This way, when the destination server receives the request, it knows that the request has been made for the web server and needs to be forwarded there. When the remote server returns information, the port numbers and IP addresses are reversed. Now, the port 80 is the source port and port 65,263 is the destination port. This way, the computer can keep track which application made the request and delivers the data to that application. Let's assume if you open another tab on browser and want to view another website, the destination port remains same, but the source port will be different than 65,263 because it is already in use. Now this is how the system knows which tab on the browser made the request. This example shows just port numbers because we are still talking about transport. In reality, a packet is only sent along with the IP address or MAC address. I just wanted to show you how port numbers function. Now, this is how computers can keep different traffic separate, even if all the traffic is being sent over the same wire. Once the data comes to networking, system adds source and destination IP address to the already existing data. Now, the segment of data is called a packet, with data, source, and target port and address and target IP address. Now, at the next level, which is data link level, the source and destination MAC addresses are added. Trailer is also added, which helps in checking for error. We will talk about this in one of the future videos. Please pay attention to the sequence of data attached. At this point, the entire package is called a frame. Now, this frame is ready to be sent over Ethernet or Wi-Fi or fiber optics. Now comes the physical layer. This is where the data is exchanged either via Ethernet cable that you can see here in the picture, or via Wi-Fi or fiber optic. At this point, the information received from the layers above is converted into ones and zeros so that it can be forwarded over cable or Wi-Fi or fiber optic. Today we looked at the process how information that originates from application like browser is prepared for sending across cable to the other computer or server. Now it is important to know that this step-by-step process so that you know the different stages and you are able to analyze and troubleshoot issues in case these arise. Congratulations on completing this lesson today. If you found this information useful, feel free to share it with your friends and family. And if you have any suggestions, please feel free to provide those in the comments, and I'll be happy to incorporate your suggestions. Consider subscribing so that you get notified about new videos that I post here. Accelerate works with students and startups by providing them with high-performance, low-cost laptops, desktops, and computing accessories. If you are in Canada and want to know more about Dell laptops starting at just $400, then send an email today at the email flashing on your screen. Thank you so much for learning with me today. I'll see you in the next video with a new topic. Until then, happy learning.